Okay, so the fracturing is finished. It took a while, to be fair. It's mostly the glasses. I think it took around an hour. So it started at 10:46. The first one finished at 10:46 and finished at 11:41. So it's little under an hour. And files are quite big, but that's actually because of the glass. I think we may have over did the glass in terms of pieces. I mean, that kind of looks right. If anything, it will be probably smaller, but you know, it's we all have some memory limits. But if I unpack this and then explode it, I think we can do something like this, because these are all packed now, so you can really split the glass quite fast. Actually, we can do that with a bit more procedural. So with the selection tool, we can go by name, RBD type. We can say blast glassed, and now we don't have the glass, and then I can probably unpack it. It's going to be a lot faster. And then if I pack, for example, back to check how many pieces, because it kind of like relates to how fast this simulation will be, using the name attribute. 139,000 pieces, that's all right. And if I do an explode view, does it work with packed? Yes, it does. So it kind of like has enough granular fidelity, I think. So each of these pieces will be able to move separately, and since it's a huge object, as long as it kind of moves together, bands, and does its thing, it has enough detail. All right, so let me pause this, blast this away. Let's have a look at another one. Let's look at one of those small ones, 248 megabyte. Let it load. Please do visually check each one of them to see if there's anything unexpected, like a really stretched G or something. Basically, when you do space G, you should only see the building. If you see something like this, then you have some crazy geo that went somewhere else that for some reason, and that's not a good thing. Anyway, now let's I think now we can start building our building simulation network. All right, so that's gonna go in here. Let's drop in a geometry node. Let's call it building sim. Okay, let's dive inside. Obviously, we want to simulate this on the environment, so we need to do a scatter, which we haven't done yet. So let's bring in our terrain. Let's pin this. So we need to go to our terrain. Dive inside. Oh, it's calculating. Okay, you left the flag somewhere else. We didn't want it, I guess. Okay, I don't need any of those cooked ones. I just need something from top. It's this guy to scatter. Initial frame, because this one. Okay. Let's go back inside building sim. Okay, so we have a lot of attributes here. I think we don't need. What I want to do here is just, this is not time dependent, no, so just convert to height field. We can go half of the density and just the height field. Plug this guy in, let it cook into geo. Okay, it's even more than X3 actually. I think this goes the, yeah, we can go 0.25. All right. So because I'm going to use this for scattering, what I want to do is I want to get rid of some of the edges so I don't have a half scattered building on the sides. Okay, so, well, actually that doesn't matter because we're gonna do a simulation area selection that is in the center. So let's do something like this now. This is what I'm going to copy from my other scene. They're just boxes, and I'll just go through them one by one instead. So these are landscape, right? I have basically I have these boxes here representing my neighborhoods. Okay, I will now move these around regardless. So then I am just blasting some of these faces away and just putting a scatter down, just keeping the points. So if I do that, so it's just keeping these edge points. This, if you don't, you're gonna have more houses. This is fine. Let's go with this. Now let's ray these points down. Okay. This goes here. This goes here. And I'm gonna say minimum distance. A little offset is fine. So they're gonna snap to the bottom. Okay, I have 24 buildings. I'm gonna end up having 24 buildings. Okay, now I want to bring some instancing, right? And some random rotational. I think I should probably first load in the instances and then show you how I'm rotating them. Okay, so something we need to create first is the building ID on these points. Okay, so if I go to the points, I have these random points with absolutely no information. So let's do something like this. Let's drop in an attribute wrangle now. Remember, we baked the buildings already in the unbroken buildings. Then we're going to swap them with the broken ones. These one here, right? In here we have all these buildings. We're going to need that path. So let's copy this path as well. Actually, we're going to need an entire path with the building. One of the building is inside, so there's a number that goes here like this, and that's going to be our we're going to populate that with a random attribute from our expression. So in here, let's type integer add building ID as bid again. So I'm going to create a random number based on position or point number. Let's do it based on point number. Okay, so that gives us, as you guys know, this is an integer, so let's turn it to float so we can see it. Random float. Now I'm going to fit that to the amount of buildings I have. Okay, so fit random value is always 0 to 1, and I want this to be 0 to 9 or 10. Let's check what it does. And I want this to be integer because, you know, I'm going to use it as an integer. So here's the thing: if the result on the right side is a float, and if you're expecting an integer, if you're requesting an integer, it will work, but it will say, hey, there's a attribute mismatch, float to integer. The way to fix that here is to say convert the result to integer before declaring it as the BID. So that's gonna fix there. So now I can look at my smallest number is 0, the highest number is 8. Okay, so that's gonna be 10 because rounding it. Okay, 0 to 9, because I have 9 buildings. Well, actually I'm using 8 of them, right? So let's put 9 here. Okay, so we have this bid now. So now the bid can do something like this. If I put an instance up, then I'm gonna put this, call this building ID. Building ID. Now I can use this value to load my pre-calculated buildings. So how does that work? Then I can say s at instance file equals. So first I'm gonna paste that path I wrote. Let's expand this. So this is where we wrote the paths, right? So that's not gonna work. It's gonna look, well, it will work, but it's gonna load only one building. But we don't want that. There's a function. If I go here, actually, let me select this guy. It is a semicolon. Okay, so if I plug this guy here and say use instance file as my attribute to bring in the mesh, unable to read heap. Is it not correct? Oh yes. Here. Okay, so now it's all loaded 0, right? So I need to somehow randomize these values so I can load the these are the unbroken ones, that's why it's loading so fast. So the way it works is I need to be able to manipulate the path somehow in Vex, and we use sprintf function for that one. So sprintf, then you open a parentheses, and then you close the parentheses here, and then you say, hey, this is my path, but I want to randomize this, I want to edit this with an attribute. Then you go %, I, because we're going to put in an integer, or s for a string, comma I at BID. Now it should replace the buildings, and it exploded. Oh, wait, here. Parentheses in the wrong place. Okay, so now it should load, because taken down, I guess working. It should load different building, but they're all exact same orientation, right? So this is something we need to fix it as well. So it's a bit more random now, good, but they are not doing the right thing as in orientation. So now what I'm going to do is I'm going to create a 90-degree random orient values. So let's put up another attribute wrangle. Let's go here maybe before we load it in. So then I'm going to say f at rotate So I've got this from somewhere from internet, but I'm sorry, I forgot your name, so I can't really credit you, but thanks for the simple solution. So basically now I'm saying I'm creating a rotation degree. Okay, I'm declaring a value, and in order to pass a variable into a vector, you need to use set function. Okay, and then you put in your attribute, and in this case I think we don't even need to declare it, so we can just say float, and then we can say rotate only here. So then this results in a value of 090 named rotation degree. Okay, then I'm going to create I'm converting that to quaternion. Okay, rotation degree, rotation order. We need to create a rotation order. Let's say 1 integer rot order equals 1. Okay, and then I'm create is this everything correct? And then basically I'm exporting that out as an orient attribute. Orient is a P type, so it's like P is a quaternion, V is a vector. So then I multiply my orient with rotation vector Q multiply P at orient rot quaternion. Okay, now let's let me see if this worked. It's hard to tell. Oh, it's taken a while. Maybe we can do the bounding box a little bit faster. Oh, but they're all same. I guess we can then multiply some with random value, so some rotates, some doesn't. Okay, I had to change my code a little bit because it wasn't really randomizing it properly. So basically I just create a random, I just changed this part. A rotation order is now a random point number times 8, but I'm flooring it to an integer value, so it's like 3, so just some random number based on point number. And if I look at the result from, let's say, top view, so that's before. So let's have a look at these guys are same. So right, these guys are same, so it kind of like turns these around. Some are still same, but generally if this is our angle, it will be probably okay. Okay, and we'll continue. So what I want to create now is just a little randomization as well, so they're not perfectly aligned. I mean, I guess in a city setting they're perfectly aligned, to be honest. Like they have codes and stuff for this, but let's drop in a attribute randomize, and let's say I want this to work on orient, add a value, not this much, that'll be crazy, maybe this much, but only on one axis. So this is gonna be 4, 0, 1, 0. So if I look again from top, so that's probably way too much. Let's go 1, something really, sorry, gotta normalize this. Let's go, oops, maybe 0 0.01, a few more randoms. Okay, let's look, have a look, a little bit more random, a few ones angled. All right, now what I need to do is to figure out where my crack was, which is somewhere here. So let's template the animated terrain. The animated terrain is animated land. We can use this one definitely. Let's put the flag here. Let's let it calculate. Okay, now let's go back in our building sim area. So let's load in the other geometry to be visible. Oh, we didn't put the flag on here. We need to put the flag on. Okay, so we have these buildings to simulate. So that might be a little too much, but why not? At least we can do a test area like this, and you guys can decide what you want to simulate. So basically anything that is in this edge will fall down into their demise. Now let's go, I don't want this to be visible, that's not that, that's here. Okay, let's go in here. So let's do something like this. So basically all this I want to move it to land, and all this in the center I want to destroy, right? So let's do this. Let's put a box. Let's call it to sim, or sim area. Okay, let's make this something like, I don't know, it's probably roughly in the same numbers, so 560, 500, 953. If we look from top, so that's roughly it. Just needs to keep the center points, so this will be all the buildings to simulate. Maybe not these guys. Well, actually, let's keep those as well. Maybe they'll fall. Okay, and now I'm going to create a group. I'm gonna call this bounds, sim bounds points based on bounding region that is an object. And now I'm gonna split this group. And I'm going to say you load only this simulated objects, but I still have the points, and this is where I'm going to actually move the am I using the BID here? No, so I can take this guy down here. Okay, because this is the part where I'm gonna say load them all as boxes and load the fractured one instead. And here I can say load them as you like, they're not heavy. Okay, because these ones we're not gonna simulate. They're gonna be traveling with the land. And we're gonna point deform them here, so they travel with the rest of the land, or we can put them somewhere else to travel. Anyway, so now let's change the path of the building ID, fracture building IDs. Let's call this fracture building IDs, render building IDs. Okay, now we need to change the path to our fractured geo. So where was it? It was here. Let's dive in here. So this is going to be very heavy, so that's why I switched to the bounding box. Okay, I can put a blast here and just blast all the points and do the same thing. It's kind of the same thing. Okay, and I'm going to need that as that, and just gonna replace the string. Okay, let's go in here, paste. Okay, now we're gonna load our simulation objects instead. So now I want to create a wrangle that is gonna be blowing the VH ID based on point number. Since this point numbers are going to change, but we can do the no, I can't do the BID because some of them are repeats. But that's going to basically gonna keep me, if it will say if the point number is 0, is not matching 0, the attribute coming from here will blast everything else. So this is what it's doing, right? I have only one. So this way, now I can load my well, it's already loaded actually. Sorry, yeah, it's this guy, right? So that's the very corner object. Well, you know, I don't think I want that. That's not in a very nice place. So let's do something like this, because that's kind of what I did as well to avoid that. And I skipped it at the beginning of the sim, but I think I should have. Let's say if you want to shave off the edge of something, it can create a bound node. Okay, then you can plug this guy in here. It's gonna put a box like this, right? It's based on this guy. Then puts a box around it. Then you can say shrink it by 100 meters. Okay, 100, 100, 100. Then I can say group this using this object. There's many ways to do it. This is one of them. And then say delete. And I can put a blast. Delete, keep bounds, bounding object again. Okay, so now it will not scatter that far into the environment. Now it looks like at the edge, but it's actually not. Okay, let's remove this. Let's bring in our simulation geometry. So it's kind of like a bit more inset now. Okay, where are we? Now I want to sink this guy a little bit inside. Remember, it's like right now it's just sitting, but I'm gonna sink all of these buildings. I think like 30 meters in. No, this is not the correct node. Sorry, I'm going to. I have a transform here that says this is called keep wedge. Where am I? dy min, so it's getting the dy min minus, it's getting this value which is my lowest position, right? So if I have a look here, no, let's have a look here. This object needs to be okay. Oh, I have a minus here. Why do I have a minus here? Okay, so let's have a look here. So it's too much, it went down too much. Basically now I kind of sank the object deep inside, right? It's because, let's say it's like a foundation, so it doesn't have any floating areas. If I unpack this, we'll try to unpack with the glasses. I probably should have packed the glasses before doing that, to be honest. Let's do it like this. So this is kind of before, this is now, it sank a little bit. Maybe let's do 20 meters. Maybe we don't need that much. Okay, let's do 10 meters. Okay, so I just sank it inside the inside, basically in the land. All right. What else I want to do is now, basically after I unpack it, it's taking a while because trying to load the glasses. We should have declared the glasses as a pack them as a bounding box anyway. So now I want to blast my glass again based on the name. Okay, I don't want to simulate them here. This is gonna go some other time, and I'm going to create another branch for glass, but this time I kind of gonna have to do this again because I want to do a different wedge for the glass. So this is gonna be pretty much another branch here, but we will leave that. We will leave that right now. Okay, so the next thing I need to do is to RBD unpack. Okay, let's save this, by the way. It's a good time to save. Let's call this RBD part 0. RBD buildings, RBD buildings part 1. Okay, so now I have everything exposed. What I want to also create is, okay, so I don't need that class attribute, it traveled somehow, let's get rid of it. So we're going to create the constraint network first, but again keeping it clean. We just need the material, position, and name. So I'm going to create a rest attribute here. This is important if I want to stick decals or anything, or stick displacement or nose on this geo. And this has to be a static value that doesn't change over frame range, even though the ground is moving. Okay. And now basically I am going to first create my network boxes. So let's do something like this. So this is the scatter. Right, this is my scatter area. Layout, city layout. Okay, and this is my wedge prep, which is gonna be actually quite a bigger one with the glass and other stuff, but let's keep it this big for now. So that's city layout, and this is RBD RBD load assets. Okay, let's go down here now. So we have the rest. Let's put a null. Let's call it 2 constraints. Okay, so now let's start putting our blasts when we have groups for this. We put a blast here, we can go here, let's say antenna, delete non-selected, let's try everything else. I don't need to load the background anymore. This is antennas, okay. Next is column, full columns, not just inside or outside. Okay. Column. Next is, I think, floor. Next is frame. Let's see if I remember correct. Yes. Next is the shell. Is it a capital S or is one there all small? Okay, shell. Okay, next is sidewall. Why is it outer wall? It's outwalls. Okay, and then there's the wall, and there's the lights. Interior wall, what is it? Just wall. Okay, so we loaded all of this. Oh, sorry, the lights as well. Okay, so now let's go back to antennas and let's create our constraints. So we're going to drop an RBD constraint from rules, and all of these except input groups. So you can actually do one chain, but then that will be like an awful long network. So that's why I'm kind of like doing it this way. It's a bit easier to manage and see, and you can merge them anyway at the end. So we have antennas here now. They all have a unique name attribute. How do I know? Because we made it ourselves. So if I said do a selection based on, you know, name attribute, when I move this mouse, let me show you here, for example, on the floors. The key to a good name attribute for simulation is when you do a mouse over after you pack or not, you will never highlight another object where your cursor is not. Okay, so it's like if what happens is sometimes happens quite a lot actually. You try to highlight something here, delete a packed object, and then it picks up some other object here. It means that something went wrong. This is very important. Somehow it happens. I actually don't know why it happens. Still happens though. That's why here now we have. That's why after every fracture I kind of because at some point I guess I make a mistake someplace and I somehow merge them so they break, and that's not a good, because then it means a piece here will try to move together with piece there and it's just going to look super weird. Anyway, these are the antenna connections. Antenna con. So this will be the naming convention. So the antenna connection will be using the antennas group. Well, actually I don't have to do that anymore since I split it. And if you want to observe what it's doing, you can have a look here, and these just created primitives from one to another with rest lengths basically. Now I want to create, for each one of these underneath, I need to create RBD constraint properties. Okay, and then I plug this guy to here, and I'm gonna give it a name, antenna con. Actually, just I guess const p1. You know, so when I duplicate it, move p2, p3. Let's move on. Let's do the columns. Columns is also center of mass. I actually didn't have to use that, but I wonder. I guess I was doing this first as like this long chain, and then I decided that it was way too long, and I changed my mind, I suppose. All right. Sorry, we didn't change the settings on the first one. So what I'm using is hard constraints. Okay. Why hard? I don't know. It works for me. I like to control, I guess, when they break, how they break a bit more vigorously. So I'm using hard constraints. If your objects don't need to bend, regular is glue is much faster. It also depends on how many constraints you have. It's a little tricky. I'll do the same thing here anyway. Oh, but we want to give these colors because later they're easier to identify. And I'll go like this color one by one. Next one was this is what column con. Column. Okay, this is also hard, and this time it has also color, but it's this color. Okay, and also you see, like for example, there's a two-piece here. How strong you want it to be. What you can do is that if you go here and if you want constraint network to be a bit stronger, you can say make two connections, and if you increase the radius, it should increase the amount of points. Yeah, it kind of did. Let me see. I think I can show that better here. Oh, this is let's put this on a black background. Maybe it will help. Yes. Let's have a look at this guy. So then I can say, because this one here doesn't show, but if I go here and say 0.1, maybe 1. Okay, see, kind of like reduced. So, but we're gonna keep that in default now. It always requires some tweaking, regardless, because we are not really building real buildings, so we don't expect them to fall real without customization, unfortunately. There is really no secret sauce for this. Okay, next thing is floor connections. Let's give it a nice name. And the same thing for here. No, not here. This one, copy, paste. Here, I think it's still same, but I'm gonna check everything one by one. Okay, not the floors. So why? The floors has a different setting. Okay, the floors I'm using surface points. Okay. Now let it calculate. May have changed the settings a little bit, but okay. Why am I using surface points? It's because where the constraints are positioned. Okay, so if I have a look here, this is going to, I think, take a little time. Let's see how many. If I put a null, because I want to visualize the amount. So that could be a little too much, but basically when you go surface points, constraints are put inside faces of the neighbor. So it's like you take two pieces side by side, you cut it from the center, and the constraint locations are put in. Actually, I need to draw this. Open my drawing app. I wonder if there's a RBD constraint types, Houdini. Okay, let's bring this guy in as well. Okay. I think, well, it's makes a bit more sense. Okay, so surface points creates constraints connecting closest point from nearby pieces, right? So we've been using center mass, which, because these are packed objects, it puts it at the centroid. So it means each piece ends up getting one root constraint. In surface points, you can have more points pointing out, and hinges is the one that creates a zero length 2-point prim constraint placed at the intersection of the two surfaces. So I'm going with surface points now, and if I draw something about it, it kind of means this, right? Let's make this a little smaller, a dark color. Okay, so it kind of means this. So if I have an object, let's make it a bit thicker. And let's say I have one object here, side view, another one here. So the surface points is going to create constraint here, here, and it's going to connect it like this. As opposed to center mass is going to create a constraint here, a constraint here, and it's going to connect it here. So I find this red solution to be the nicest one to create the effect of bending, because then it has its rotation center is much more logical here. So then this is more likely in when I use the surface points node, but it's slower. Okay, but you know, it's okay if it's slow. One of the things, maybe it's worth mentioning, when we are working for so what is slow, what is fast, right? When we are, because it happens quite often when I'm working for a show, sometimes I hear things like, oh, it's a really fast simulation, 30 minutes. But does it have to be 30 minutes? Do you think we can have something really nice if it was 3 hours, 6 hours overnight simulation, and we probably could. So prototype your simulations in low res, let's say, but there's really no point to be proud of a simulation that is 30 minutes short if it's not looking epic enough, right? So, and especially if you have a farm overnight, let it cook. We want high resolution simulations, not fast simulations. Anyway, we will continue now to, so this was the floor, right? The floor is like this. Constraint, we didn't change the color. Let's go to the next guy. And in this one, I think you can change the size of the constraint so they're a bit more visible, but I don't think it's from here. No, the guide scale, you can do it from here, yes. If they're not so big enough. I think this should work. Let me see if it does. Make them bigger. Yeah, okay, they're kind of bigger now. That may be way too many, so we are going to reduce these. Let's see if we can reduce them using the floor connection settings. Maybe let's go search radius smaller. Maybe calculate it a little faster. Maybe it didn't. Oh, maybe it did. Hard to cap. Let's do this. Let's put a null. Let's observe the results. Okay, I think it did. Let's change the max point count. I'm gonna try to put 10 here to see what it does. It's so much. Is it so much faster? No, it didn't change anything because it needs to be recooked. Yes. Okay, maybe it's not that much. Well, here's the other way to delete too many constraints. It's just it's not too much. It's just struggling to show them because there's too many overlapping geometry. So let's go. Don't show me. Show me points. You can't see them here, but they're actually barely visible points. Let's continue to frame. Frame is going to be the same surface points. I'm just going to actually go manual, copy paste. Let's call this frame. Okay, and let's give it a different color. Okay, let's do the same for shell, I think. I do want to see though how many connections it's gonna make. Let's go here. Let's cook this now. Shouldn't be long. I don't know if you guys can see the points. Maybe if I change it to because they're not points, they're really small primitives, and that's why they're really hard to see. I mean, the recording should show it fine. I'm recording with a good bit rate. Anyway, I guess if I switch from frame to okay, let it cook again, and just want to show the difference between this guy and the next guy. And it is okay to all start with the center of mass, and then maybe later change to surface points. There are other tricks that I usually do. It's because I know that all of this is going to collapse, and we will barely see anything not collapsing. So you can also put delete swaps and randomly delete some of these constraints. It's going to make the building collapse easier because we do want them to collapse anyway. This is taking forever. Okay, I'm going to put a pause on the video, and I'm going to redo the exact same thing for the, I have to stop selecting things while auto update is on, and I'll do the exact same thing for the rest, and then I'll get back. Okay, so I did that now, and here on the left side you can see some points, some lines based on constraint types. We are not creating internal constraints for lights because they're not fractured. So these are called internal constraints. Okay, so these are not connected to each other. So if I simulated this as is, a wall will fall internally connected to itself, but it's not going to follow the underlying floor because it's not connected to the floor. So let's put a network here. Let's put a network here and say call these internal constraints. Internal constraints. Now we need to connect those frames to the walls and walls to the floors and whatnot. How does that work? Again, we're going to create RBD constraint from rules. Okay, and we're going to bring in our object after rest here to the left input. Then we're going to connect the output to the constraint geometry. Okay, because now we need that information down, flowing thing down. I need to say things like, hey, create a surface point. So the groups, we're going to change the group to group. And this first one is named column to floor. Okay. So then I need to choose column as my group one. Where's my column? Column is going to group one. And I need to choose floor. Where is my floor? Floor as group two. Okay. So let it cook. So if I put a null here, and if I actually remove this guy, you're going to see that now columns are connected to the floors. And this can be, I think, because using the nearest one, and this could be, how to say it? This could be, so if I want to visualize this, I'm trying to show you guys. Okay, it's going to the center of the, ideally I don't want, but for speed's sake you could leave it as center of mass, but I'm gonna change it to see how it makes it, of how fast it makes it for surface points. Again, so let it cook. Okay, this one was quite fast. I think with the columns I needed to increase the surface search radius. Okay, this is kind of now connecting much nicer to the grounds. Okay, so what I'm going to do is that I'm going to repeat this for each one of these steps. Which I'm going to walk through each one of these with you. So the next thing is duplicating this guy and saying I want to connect wall to the floor. Okay, if you miss something, things will collapse a lot faster. So this is wall to the floor. I want to bring in wall from here. Okay. Come on. Wall to the floor. Okay. So columns are connected to the floors. Walls are connected to the floors. Do we need to connect anything else to the floors? I don't think so. Oh, this is still calculating. Oh no, because I need to remove this guy. Columns, wall. We could have used columns and wall in one group, obviously, like many targets to one target, or many sources to one target, or one target to many sources. But it's, like I said, it's a bit easier to manage like this. It is against surface points, and if I disable this guy just to, you know, QC what I'm doing, and if I visualize the constraints here, I should kind of have the similar thing. If I visualize the geometry, it should be putting constraints next to the walls. It's super hard to see, but that's what it's actually doing. You can blast a real small region. Actually, you know what? Let's do that because it's going to be so much faster. I don't know why I didn't think about that before. Let's just say select by name attribute. Let's just select this section and reverse it, and we'll get instant calculations. Well, not so instant, but much faster. All right, so now if I look here as opposed to the geo, it's going to be easier to see what I'm doing here. This is my mesh now, right? This is my glue, so it's still hard to see, but they're there. Anyway, we'll continue. The next thing is frame to floor. I'm not going to visualize this anymore. I'm just going to populate them. The next one is frame to floor. Okay, so that's going to be frame to floor is going to be obviously frame to floor. I just had to be careful with the typos here, just not to make them. Okay, next will be side wall to floor. Okay, we're basically bolting them. Copy. I'm gonna put this on manual. This should be fine now. All the information we already have. So this has a name. Side wall to floor. Sorry, side wall to floor. This is using sidewall. This is the floor, but sidewall was not sidewall with us. It was outwalls. Yeah, this guy. Okay, and then shell to the frame. And ours was shell, but with a small s. Shell to frame. Okay, now we're going to define their group names and their types, because we didn't define what they are. We just made their connections. This guy comes in as well. And if I just visualize these guys here, now I should have a lot more constraints. Let that sink in. Okay. This could be our test area anyway as well. We can just drop this on the floor and see what it does. But if you guys middle click here, we're still polygons. We're not packed objects. We're not ready to be simulated. So let's create constraint properties. And this is where you can actually now start, if you want, individually changing their properties, because did we create their group names? Connectors, we need to turn those on. I think that would be useful. Let's try that. Let me see. if I can show what I mean. Group type, primitive group. So let's turn those on. Let's create groups for these connectors, okay? You don't want them to be just named connectors, so you want them to be column to floor. So if I do a middle mouse now, you're gonna see, was it an attribute? Here, let it cook. Oh, we missed something here, a group here. Connection tab, so this should create the group, no? Or was it an attribute? Let me see. It's not here. Oh, maybe, yes, sorry. I think it's like this. Yes, so it's creating primitive groups named column to floor. So let's do those in case we need them, which most likely we will, or you will. Again, just, you know, copy the name of the node, enable group type, primitive group. So if you need to do very specific soap solver things like, hey, I would like this area of the shell geometry to disconnect when the camera is flying. So you can say, this object, this I want this to come loose. So this is basically, you have a group name, and then you have object names too, but it's probably more confusing. So this is the way to do it. Basically, you have a group, you can say remove primitives at this frame inside the simulation, and then it will remove those glues based on the group names, which is useful. Let's see if we have a look here now. We're gonna have all these guys. Good. This is why it is going to be named properties P7. They're all same. We could probably create different colors too, but I won't bother. Let's go pink, and let's connect this guy to here, this guy to here. And I can now use this to work on excuse me, on these groups, which is not visible, but they are actually visible. They're here. So if I select this guy, this should see them. Yes, so I want all these, right, specific ones to do the job, which tells me we should probably create those groups here as well. Yes, we should. Primitive tag, says select all this, say primitive group. We should, okay, it's easier, don't copy, just say $us. That's just way easier. Okay, my mistake. We can do the same thing here as well. Not this last guy here. $us. Sometimes I forget to. All right, let it cook again, because we changed things. It's gonna change them, right? Just making sure that we have the group. Yes. Do we? Antenna con, all these connections are here. Maybe this should be named con as well, because they are, after all, constraints. So if I need to isolate all the constraints based on a group, I can use a wildcard. So let it cook. Okay, cool. Now I'm going to convert my objects into packed primitives. So how do I do that? Because they need to be packed in order to be able to be simulated, and that's called RBD configure. Let's check if we need to do something with these. Oh, yes, these are hard constraints, and I don't want to change the color of everything. I want to change the color of, maybe we can isolate these based on names, internal. Okay, so let's name this con2 connection 2. Okay, which means like isolating these as a connection to another piece as opposed to not being internal. The other one internal, it doesn't matter. Okay, let's go back here again and let's color these only if it's a con2, so we can do that. And then we keep so all the pink ones are internal connections, and we can give them a different colors if needed to, but that's fine. They're all hard anyway. We can change these later too. So now, first thing, we're going to configure the antennas. Let's go here. Let's go here. This is RBD antenna, which we don't have here because we don't pick an antenna side. Or maybe we do on the sides. Maybe we do a few here. Okay, there's a few here too. All right, cool. Our antennas are grouped as antennas anyway, so they're going to be antennas. So they are metal. They're aluminum, I guess. I don't know, or copper or steel. Doesn't really matter. It matters based on its density. It's just it's going to say, hey, if this object hits that object, it's going to bounce it around. The collision shapes. We're feeding in convex alpha these guys. I don't think I have anything else adjusted. Then let's copy paste this. Now it packs everything, but defaults everything else to a default value. So what we're going to do is that we have to go with each one of these guys. RBD column, using the column group. Make sure you just don't skip one. Where's my column group? Okay, they are still there. They don't show because they're not packed, but they're still there, so it's columns. Maybe bugs to consider. Obviously we can do this with like this as well, but then you have to dive in and switch through numbers to see which one is the correct one, which one is not. So I'm rather doing it this way. So this is a concrete. It is in the list. These errors, I know. Well, is it a concrete or because it has steel inside? I think it's steel. I think it is steel. Or a concrete. You're not on the list. And it's a dense concrete. Anyway, see, it has friction and stuff. Just creating some random stuff basically. Let me pause this and I'll do the rest. Okay, I guess I tried to make them based on naming after, but I don't think I'm gonna do. Maybe I should do the instead RBD metal. Yeah, I think that makes more sense based on type. So blow it away. Let's call RBD metal. Okay, let's call RBD concrete. Maybe RBD strong metal or heavy metal, light metal. Okay, let's bring this guy here, RBD light metal. Yeah, that's basically three of those, right? RBD concrete and RBD not wood, but light concrete. Light concrete, like walls. Then light concrete, RBD heavy concrete. Okay. Now let's make sure that we distribute each one of these objects properly. So light metal would be let's cook this. So let's see how many groups we have. Right, we need to have, we have 1, 2, 3, 4, 5, 6, 7 groups. Okay, so we need to distribute the 7 groups properly here, but I think I want to write them down so I don't forget them. Okay, so we have antennas under the, I guess, light metal. We have antennas. Oops. We have antennas. We have frame and shell and out walls, basically, because our out walls were like metal plates. Under heavy metal, we don't have a heavy metal. Well, we have the columns, I guess. No, that's going to be concrete. Do we have a heavy metal? Let's make the out walls heavy metal. Oops. Out walls. Okay. Then we have heavy concrete. Heavy concrete. Heavy concrete will be columns, I guess. So there's 1, 2, 3, 4, 5 columns. We have floor and we have walls. They will be light concrete. Light concrete columns. Well, the floor. Okay, light concrete. Yeah, concrete columns. Light concrete will be wall and floor. So 1, 2, 3, 4, 5, 6, 7. Okay, good. So light metal, basically copy this, remove the columns here, not those columns, semicolons. Okay, this is done. Heavy metal is out walls, and RBD heavy concrete is columns. And then RBD light concrete is wall and floor. Now we just need to plate the settings. Lights will come after. Well, no, lights will come now actually. Let's go here and say, because that's the only thing I think left. Define RBD. Let's call it plastic. And that will be just lights from here. Lights. Oh, we need to create the light constraints also. Okay, let's do that too. So lights don't just fold themselves. Let's do it here. So lights inside themselves, they didn't have lights. So these are two lights are connected to floors, which is the ceilings, right? Floors gone to, okay, floor. So it's gonna be floor lights. Is it just lights or light? It's lights. Here, this guy. That should be okay. All right, and here is the lights. Okay, so now heavy metal is going to be metal, and it's going to be not heavy but strong. Steel. So concrete's the out walls are going to be strong. Wow, that might be actually way too strong. You know what? Let's not have heavy metal. Done. There's no heavy metal. There's just metal. There's light metal. Okay. Light metal is aluminium. That's a light metal. Used for decorations, right? RBD heavy concrete. So this is what's holding the building standing. So I think I'm gonna go with steel with this one. Okay. Light concrete. This is concrete. This to crumble sometimes. This could be lightweight. Okay. And then finally the RBD plastic, and that's gonna be, is there plastic? There's no plastic. We can go, I think, light metal or wood. Yeah, I think wood should do. Any wood. Plywood. Okay. Now if we cook this guy. Okay. Well, basically right now this is ready to drop and simulate. So let's save, and let's save this part 2. And first let's do that test before moving forward. So let's drop in RBDBullet Solver. RBDBullet Solver. So we need to check if it's exploding or not, right? And hopefully it won't. We don't need to bring in this last guy because we're not using it. And this should be quite high. We need to adjust. No, it's not. So let's just let it drop. Basically, we have no idea what's going to happen, but let's press play and see what happens. See if it's going to explode or not. Let's pull out the result. Oops, my bad. Null comes here. This, nope, sorry, comes here. Okay, so I'm not pulling in the excuse me, I'm not pulling in the glue to visualize. That should be it, really. Oh no, we need to, because we don't have a ground, so let's turn on the ground collisions. No, don't emit RBD. Use collisions, ground. At the ground plane. Use collisions, yes. Bullet, yes. Everything yes, except my breaking constraints, breaking thresholds. This is where we're gonna adjust the breaking thresholds for all our groups. And I used values like this. Let's put them in. But again, these are quite artistic values that requires random settings, pretty much testing. So you guys have to say, oh, it's breaking too easily, increase this, increase that. So I put 775 million for force threshold. I'm just gonna turn this off now and see, just use angle to work with it. Okay, let's press play. Let's see if it's gonna do anything. Let's see how slow it is or not, or if it's gonna explode or not. Okay, is it gonna speed up? We have some error which may have to investigate. This is taking a little too long, maybe. So we need to check why is it taking too long, or what is taking too long. Okay, let me pause this. Let me investigate this on pause to see how we can optimize it, because imagine the entire building, this is going to be super slow. Okay, I removed, I think, 70% of the constraints with the deletes up here. If I select it, I think 70 or 80. Let me see. Can I select? No, I had to pause it. No, 80%. So this is actually quite fast now, but we'll see how strong our building will be now once it hits the ground. But it's kind of like a few seconds a frame, so I think that's reasonable for this many pieces. I think it will be like a minute for the entire building. And then so the more constraints you have, stronger your building will be, less constraints you have, faster the simulation will be. Then you have to increase the breaking threshold so things don't break so easily. It's a balance game. What we need to do now is that let this calculate a bit more. While this is calculating, actually I can, it's kind of start tilting even, maybe one side is heavier. Well, it still has a long journey down. Okay, let's do this maybe. It will be cooler. Let's put a box, and let's say so what happens is we don't have proxy geo because we're as proxy as it gets, but you can wire in the third input and drill everything you want to do with the packed objects to stop them from simulating or override attributes. So we can do something like this, which we do a lot in the storyline anyway when it comes at that stage. So you can do something like this because these are all packed now. We can say I want to simulate just one half of this and the other half to collapse. So you can do something like this, and then say anything in here, anything in the zone. Let's do a little bit like this, and maybe rotate it a little bit, slightly bigger to make sure it's inside. Yeah, okay, and side view. All right, so you can do something like this. Group. All these objects are by default. We're gonna make them static, so we're gonna say attribute wrangle. Here we're gonna say make static. You can do those from here too, but then you have to select all of them. So we'll say make static. Make static. So nothing will move. Okay. I at active equals 0. Then you can say group based on bounding box, static points, bounding object. So you have some static points now. Sorry, if you make everything active, yeah, because this is, we're doing the opposite. I want everything outside the box to move, so I'm making everything active, but then I'm gonna make whatever is inside the box static by saying use the static group here, this guy. So anything in here now won't move, won't calculate. That should go a lot faster. Then let's put in a collision object. Let's take this guy. Let's put it under here, and let's put it slightly in front, so whatever falls, half of that will collide with that. That goes into collision geo. And now let's simulate to see what happens. It should be a little faster now, so we can just to see that our collision is working, just to see that our constraints are working. They're not crumbling. They're holding themselves a little bit better than we would hope so. And while this is it coming down? It is moving, right? It's moving a little fast too. Yes, this part is falling, but because now the glue is holding, I think the glue is holding too strong for the rest of the part. Anyway, you know what? Let's just play blast this properly. We have a collider now. Let's just assume everything is active. And let's just play blast this. Be patient. For myself, I'll put you on pause. All right, let's go. I don't know, 100 frames. Okay, I'll come back. Well, let's not disable the collider. Yeah, that's the collider. We can push that a little to the left, I guess, before continuing our simulation. let's play blast this. Okay, I'll pause the video and I'll get back to it once we have the result. Okay, I did simulate three variations with different values. So one thing is that 20 makes no sense here because I forgot these are radians. So you can just convert this to like in Google, you know, it's I think divide by pi. If you type angle to radians, because like, you know, we like to think in angles, it's easier. Like I want to say if anything rotates more than 45 degrees, you know, break. So you can say angle to radians is there's like you can just convert in Google. So let's say 45 degrees, so that's 0.78 radians. So that's something like that. Or if you want things to, you know, dangle a bit more, you increase this value. So what happened is at this scale with this many constraints, this is the current outcome. Like this guy, no, not this one, this one. Force threshold 5,000, everything crumbles. Imagine with the rest of the building, it's gonna just, you know, crumble really badly. This is like 50 million force threshold, so it doesn't break at all, you know, just some parts. And that's probably because they are the disconnected glue ones, I suppose. And then so I guess if this was the scale, this would be the roughly a good value, 5 million. So you kind of get still interconnected pieces as these things is crumbling, like these guys are together, these guys are together. If anything, probably it can be more, but that's basically the test zone, obviously. So we just have to disable this guy for the entire building, but the next step will be bringing the environment, creating some weak points, and making the bottom of the buildings follow the environment, because remember they were animated. So if we pull in object merge here, we need to anyway. I'm just gonna put this on manual. It needs to be, oops, let's go back. Let's pin the parameter, it's here. Let's pin the parameters here and let's go to terrain. And remember we created the animated ground proxy, right? This goes in here, into this. We also need to bring in the simulated geo, but that will come next. So if I bring this guy in here, so now this, remember, moves. So we're gonna say whatever is inside move. There's two ways to do this. There's guided geo, and we can actually do animated as well, but that's for the next lesson. So I'm gonna finish this video here. Let's save this as part 3, and in the next video we'll start doing the rest of the work for the entire building, and then we'll be ready to simulate the whole scene for the RBD part of it. So thank you for watching.